Okay, so today we're going to talk about so samples and surveys. So a population is what you're studying. So let's just say the population was all St. Mary's students in the high school. And so we wanted to ask them a question, what's their favorite band or something like that. We wanted to find out what the favorite band was. So if you want to do that, that'd be 250 students or so, that you'd have to ask that question to, and it might take a long time. And so we want to do something that we might do in stats, and which is to take a random sample. It's important that the sample be random. If it's not random, it's not that valid. We don't really look highly on things that weren't randomized. And so we like it to be random. So we might take a sample. One way of doing that would be to kind of like put your name in a hat. So all the names, all 250 names or so are put in a hat. We randomly select 30 of the students and we ask them the question that we want to ask them. That'd be one way. There'd be other ways of doing it. We could stratify first. We could kind of break them into groups by some means. So like maybe by grade level. So 9th, 10th, 11th, and 12th. Maybe we take 10. We randomly select 10 9th graders, 10 10th graders, and so forth. Because different age groups may have different views on music. We could, in this case, we can't separate by gender, but you could separate by just about any. You could do it by honors classes, non-honors classes. You could do it, all kinds of different ways. You could organize the students and then pick from those groups randomly or something like that to do things. And so that's just called a sample. And you would hope. Now, the thing about a sample is, let's just say that you find this is the only person I'm thinking of because some of the seniors decorated my room, that the Biebs, Justin Biebster, or whatever his name, Justin Bieber, sorry, is the favorite, band of everyone at St. Mary's. And so you cannot extrapolate that beyond the population of St. Mary's. In other words, we can't say, well, I bet the favorite band of MUS boys is also Justin Bieber. You can't make that assumption. You can't even say, Hutchinson or say Agnes or any of those schools. We can't extrapolate beyond the population that we studied. Since we only studied St. Mary's High School, we can't take that to another state or another school or anywhere really. We can't take it, down a grade. Well, I bet the middle school would be. No, we can't do any of that. So you can only kind of like the sample kind of predict, something about the population. It's more of a prediction than like an exact science. It's the stats we're talking about. So it's not going to be exact when you do that. There are different types of sampling. So the most basic and really one of the best, if you can do it, is a simple random sample. And so this is when, the idea of putting everyone's name in a hat and drawing out. Now each element has an equal chance. So it's really fair that way. And it's because it's random, it ends up being a pretty good sample usually. I think that it's not always possible. Let's say we're trying to measure the height of every woman in the United States. Well, I don't have a list of every woman in the United States, so it's going to be hard to put all their names in a hat. Even if I could fit them all in a hat, I think it'd be a lot of names. But that's the idea. We don't really have a list of everything, of everyone in the United States, for example, usually to go from. So that's not always possible. Convenience sampling is really lazy. It's not a great way to do it. It's not random, so it's not random. You just kind of like, okay, I'm going to ask, there's 20 people standing around that locker out there. I'm just going to go and talk to them, and it should just be easy and convenient to the people that are closest to me here, or physically or whoever, the closest people to where I'm at. I'm just going to ask them the questions, and that's a terrible way of doing things statistically. So systematic sampling is not bad. So let's say we're all going to a school assembly in the gym. So if that was the case, then I could stand at the door, and every 10th person systematically, every 10th person that comes in, I would ask them a question, what's your favorite band? That would be a random way and a good way of doing things if they're all coming to the same location or something, and you could all ask them that question. Self-selected sample is not random. We don't really look. This is a lot of internet polls, or so you send out a survey and to see who responds. You see that a lot at St. Mary's, actually. You see, like, it's not very reliable data, unfortunately. So like when you get all those polls in your email, and like, hey, would you respond to this? What do you think about blah? And you spend all that time. So the people who volunteer often are the people who feel the strongest about things. And so it ends up being not really representative of the whole population. So if you respond to one of those, like, I have very strong feelings about this political poll or whatever it is, you tend to be someone who has real strong feelings about things and not the regular population. Stratified samples, pretty good way. It's random way. That's the idea of breaking into grades first, or some homogeneous group. That means, break it by some similarity. Maybe you break it down by ages, 9 and 10-year-olds, 11 and 12-year-olds, and so forth. Break it into groups, and then within each subgroup, do a SRS, do a simple random sample. So you have all the names of the subgroup there, all the 9 and 10-year-olds. You randomly select 10 of them and ask them, and do that within each age group or something. Clusters, pretty tough to pull off. It's not a bad method, but it's really hard to find a representative group. And so what I mean by that is, you're trying to find one group or a number of groups that might be representative of the whole population. Let's say you're trying to study the city of Memphis. So you might try to choose a zip code that's representative of everyone. Well, that's really hard to do because I'm not sure exactly what the racial breakdown is, but you'd have to pick a zip code that has a similar racial breakdown as the whole city of Memphis does. You'd have to pick one that monetary-wise has a similar breakdown as the whole city of Memphis does. So you have some rich folks, some poor folks, some in between in a similar way to the real population. Age-wise, it'd have to be a population that has a similar breakdown. Gender-wise, I mean, you can look at all different things and say, well, it's supposed to be representative. It's very hard to do that because, if you picked somewhere in Collierville or something like that, would be, for the population of the Memphis area, that might be kind of a little bit more well-off kind of area, and it might not be representative of racially. It might not be the representative you want. If you pick it like downtown Memphis, that might not be it'd be tough to do, right? It doesn't have to be a zip code. It could be anything. Like, let's say you went to a church or a gym. Gym actually might not be too bad, but would it have that kind of breakdown as the whole city of Memphis do? It'd be very difficult, but gym would be bad in that you'd only have the athletic folks, maybe people who like doing athletics. So it's tough to find a good representative population. But let's just say you did zip codes. And so if that was the case, you would randomly choose some zip codes and survey everyone in that zip code. So it becomes a census inside of that group. So it's different than a stratified. Stratified, you break it into groups and you do a simple random sample in each group. Here, you're trying to find maybe one or two groups that are representative and do a full census and interview everyone in that group. So it's a little different in the way it breaks down. 3 basic sampling kind of overall methods here. Oh, what are the methods? A newspaper article on the tax increase invites readers to call the paper. So they're calling, the readers decide, right? You didn't choose them, they just decided. So that's a self-selected sample, right? That's someone who, it's just, it's not very reliable data that you get from doing that. Interviews people leaving the city's largest park. That seems like a pretty lazy way to do things. I have concerns that it's at the park. That might mean people who are more athletic, or I don't know, just interesting kind of, it depends what you're studying actually. That's a convenient sample for sure. Every 50th person, that seems systematic, right? That'd be okay if you have a list of folks. Pick 3 ALAPs and sample everyone. So typically ALAPs, I think, are by grade level. So they'd be kind of like, so you're trying to pick representative samples, I guess. And so you sample everyone. So that's the key. So that would be a cluster type of sample because you sampled everyone in the ALAP, you're trying to pick representative samples, I guess. Right? You pick 10 people from each grade. Now you stratified, right? You broke them into groups first. So here, the group is the thing you're studying. Here, you're breaking into groups and then simple random sample within each group. So that would be stratified. There are some methods used. And so the first is just observation. And think about that word observe. So you're just basically, observing. You're not really interacting with folks. You're not really even asking them questions. I think of observational study. You're just observing. It could be through a mirror that you can see them. It could be a video you're watching. It could be just someone, observing what's happening in a room or something. Controlled experiment happens a lot with stuff. And so this is something where there's a treatment. Oftentimes the treatment is drugs. And so you might be trying to lower cholesterol. And so half the people in the group randomly are selected and they get the real drug. And half the people randomly selected get the fake drug called the placebo. And they might have a positive effect called the placebo effect, but they're called the control group. So the placebo group is the control group. We're trying to see how effective our medicine is. And so we can compare the results of the group that got the medicine to the results of the group that thought they got the medicine, but really got a sugar pill that's called the placebo. And so if you compare them and the group that took the drug really did lower their cholesterol quite a bit more than the control group, then you might have a winning experiment there. Experimentation can prove causation. So it can prove causation. That's causation, yeah. So if you have an experiment, it can prove that one thing is causing another. So smoking does lead to, or can lead to lung cancer. So you have to do an experiment in order to prove that kind of thing. It's a little bit more involved than just observational study. Survey is exactly like it sounds like, a set of questions you ask people. You do that a lot at St. Mary's with your email. You get surveys and you respond. Types of bias. So these are types of bias. Bias is anything that makes the outcome, let me see, the formal definition, favors one outcome over another. So undercoverage bias is very, very popular. So that would be some portion of the population has been excluded. So maybe you were trying to call people on their cell phones, and some people don't have cell phones, they only have a landline, and so they are undercovered in this particular study because you didn't call any landlines, you only called cell phones. And so you didn't represent everyone in the population properly. So when you sampled, you left out a whole group of folks. And because of the location, that's often very popular. So you might be interviewing someone at a grocery store, asking them if they should go to restaurants or not. Well, if you're going to a grocery store, maybe those folks don't really go to that many restaurants. They usually just cook their own food. So you're not asking necessarily a representative sample because of where you gave the survey. It's very common, actually, is that the location causes undercoverage. Non-response bias is going to happen in every survey or study you do, pretty much. So some people just choose not to respond. Occurs, you know, you ask them a question, you call them up, and they don't respond, right? They say, "I'm going to hang up on you." Actually, the rates of responding on a phone is probably pretty low. I'm guessing 10% or less actually respond. And so those who do respond may differ from those who don't respond. So response bias. So this is, so you feel uncomfortable answering a question. So like, let's say I went up to one of you and I said, hey, have you taken drugs in the last week? You know, are you on drugs? Probably, let's say you had done some marijuana and I asked you that question, you might feel like, wow, I don't really want to tell my teacher about the fact that I smoked a little weed this week. And so you may be reluctant to tell me. And so sometimes just the interviewer, because of the nature of it, you don't want to tell them the truth about what really happened there. Even though they're asking a question, you don't answer honestly sometimes because you're uncomfortable and you are afraid of maybe ramifications or anything from your answer. So that's called response bias. So sometimes they actually change their answer to avoid judgment, or so it doesn't have to be drugs, but it could be, you know, just you feel like you want to please the interviewer. So they ask questions like, in maybe leading way, like, don't you think we should all wear our mask even when we're outside? And so you think, well, they probably think I should say yes, and so I'm going to say yes because I want to please the interviewer for whatever reason. That's something that we just sometimes don't like to cause problems, and so it's called response bias. Volunteer bias happens. This is one of the reasons why if you do like a self-selected type of sampling method where you just respond to an email, a survey, or something, oftentimes the people who do respond are the most passionate. So you might see, I go to ESPN.com, there's an internet poll about who's the greatest basketball player. If I feel strongly about one of the players, I might actually respond to that poll. Whereas if I'm just kind of like kind kind of root for the NBA, but I'm not going to respond to that poll because I don't feel that passionately for any one of those players. I just kind of watch it a little bit, kind of thing. And the last one is wording bias. I'm going to go over a few examples of wording bias here on the next page. And so, do you think that farmers should use poison to control insects on crops? And this is like just harshly said here. So I know that sounds funny, but the wording that you ask a question with is very important. And so just the fact you use the word poison, you think, oh, like, why would I use poison? Like herbal insecticides or something, like, oh, yeah, I think I would use that on crops, kind of thing or something. But poison, ooh, that sounds so bad. So neutral wording, maybe a pesticide instead of a poison. So the way you phrase a question, if we gave a question like this, it would just be moot. The results would be nothing because it was a poorly worded question. And that happens a lot actually with polls. Don't you agree that everyone should be wearing masks when they go outside? Very leading, right? So the question is, you seem to want some certain kind of response there, like, don't you think? Don't you agree? Like, yeah, I agree. I think that sounds great. But you're leading them to the answer. So this, again, it would be moot. It would just be like, not valid at all, the results we get from that. Do you think that teachers should communicate frequently with students and their parents about grades? Sometimes a question compares, there's really a couple issues in this, students and parents, like that's too much. Maybe you think they should communicate with students but not parents. And so there are two issues in one question is a no. You can't really answer that. Designing a survey. So if you were, let's say, during the Olympic Games in 2008, there was a U.S. swimmer that won more gold medals than any other swimmer had ever won. You might even know his name. What sampling method could you use to find the percent of students in your school who recognize the swimmer from a photograph? So, so you design something. So design that right now. Pick a sampling method that you wrote down, and what would you do? So one way of doing that would be to put all the names in a hat, like a simple random sample. Put all the names in a hat and draw out, 30 people and ask them the question about the photograph. So you randomly pick 30 people. Maybe you could stratify by grade. So you go to all the 9th grade A-Labs and you randomly select, 10 people out of each grade's A-Labs, kind of a thing, or something. So you could do that would be stratified. Be another. Those are really good ways to do things. What is an example of survey question that is likely to yield information with no bias? So try to keep it simple. So you want to kind of accomplish this. We want to find do you recognize a swimmer? And so keep it short to the point. Don't have two issues. Keep the wording neutral. Maybe like who is pictured in the photograph, or what swimmer is pictured in this photograph, or what Olympic swimmer. It depends how leading you want to be there. So not sure if you kept it simple. Who is pictured in the photograph would be a nice way of saying it, actually. And that is the lesson for today.